Hello, this is chapter 4, video number 2. Last video we talked about scatter plots and what they represent. We got into independent and dependent variables and what each point represents. Those are all individuals that combine the two values of your independent and dependent. Now we're going to go ahead and talk about kind of the nuts and bolts of these scatter plots and how do we describe the differences between them. Well, one way is the correlation coefficient. Notice all of these scatter plots do look different. This one's going up, and it's pretty clear that that one has a nice upward trend. This one's going up, but it's not as tight as this one. This one's going down, and this one's kind of all over the place. If you kind of squint, maybe it kind of looks like it's going down, but in general, that one's not very good. So we want to come up with a way to describe the differences between these. And one way to do that is called the correlation coefficient. So correlation, how well are those two correlated, and coefficient, that's just a fancy name for a letter or variable. So correlation coefficient for us is going to be R. Your R value, notice that is lowercase. A few different things that we've got going on here with a correlation coefficient. These can be anywhere from -1 all the way up to 1. So these values from -1 to 1 are possible, depending on strength. And in general, this talks about the strength of the relationship between the two variables. All right, so first off, let's talk about chaos. Let's talk about a scatter plot that does not have any discernible pattern. Well, with that, our R value would be close to 0. R value closer to 0 means that that is not very strong of a relationship. It's kind of all over the place. All right, now the two ends, two poles that are the strongest relationships are R is equal to 1. And finally, also, R is equal to -1. And I want to show you guys what those would look like. Very rarely would you find something this strong, but let's take a look. All right, if you had an R equal to 1, a correlation coefficient that was equal to 1, those would be in a positive pattern, and they would be in a perfect straight line. You probably would not see this in nature. If you did, it was probably more likely that it was a formula that you were investigating. But an R value of 1 would be in a positive straight line, upward slope, and going up the exact same amount. And I'm sure you could guess, R is equal to -1, same thing, except instead of in a positive direction, this one is going in a negative direction. This has a negative slope. Now, these are very, very unlikely. You would very rarely see R is equal to 1 or R is equal to -1. Both of those have the same strength. Even though this one is negative, that one still has the exact same strength. But most fall somewhere in between here. Let's say I had an R is equal to 0.8. Well, it'd be positive. It's going upwards, but it's probably going to look something more like this, where there is a little bit of variation between points. It isn't in a perfect straight line, but it's pretty clear exactly what's going on. All right, so I'm going to go ahead. We're going to do just a quick matching activity with this. All right. I'm not typically a huge Khan Academy fan, but well, this one isn't too bad. All right, so we have 4 scatter plots, the same ones that I showed you earlier, and 4 different R values. We have -0.42, -0.77, 0.87, and finally 0.73. All right, so first one, let's look at scatter plot A. This one is positive, so I know I'm going to need a positive number. And it's pretty good in terms of all of these. This is probably going to be my closest one to 1. So I'm going to go ahead and say that this one is 0.87. This is my strongest positive relationship. It's going upwards, and it is also strong. All right, scatter plot B. Scatter plot B. This one is also going upwards, but it's not as strong as the other one. So I need a positive number that is not quite as big as scatter plot A. Well, the only positive value that I have left is 0.73, so that one has to match up with scatter plot B. All right, let's look at these last two. I have one that is -0.42 and -0.77. So I need the stronger one to have the -0.77 and the weaker one to be closer to 0. All right, looking at these two, scatter plot C. This one is going downwards and this one is stronger, so that would be closer to -1. So C is going to match up with -0.77. All right, and oh, look at that. I even have a star. All right, so that is in general what we're looking at with scatter plots. So correlation coefficient can be anywhere from -1 to 1. -1 would be perfectly negative slope right in a row. +1 would be perfect positive slope, no deviation going upwards. Most are going to fall in between though. All right.